Hello everyone, welcome to Global Climate Change. This is part of GCSE chemistry, although actually can be related to geography as well, so it's kind of like it crosses over. So yeah, you may have talked about this in your geography classes at GCSE if you're taking that as a subject, or you may have talked about it before. So these are useful for two subjects. Okay, so let's get started on I'm Laura Lewis. I didn't introduce myself there. Okay, let's get started on the learning objectives. So, a description of the warming of the planet due to human activity, although we'll talk about natural as well, okay? An analysis of the effects on the weather and climate of different regions of the Earth, and a discussion of how human life will be affected by these changes to climate. So we call it climate change rather than global warming, even though the two sometimes are used interchangeably because not everywhere on the Earth is going to become warmer. So overall, the temperature of the Earth is becoming warmer over time as an average over the planet, but not everywhere will become warmer. Some places may even become colder. Okay, so that's what we're going to talk about today. So a little bit of starting question for us. So what is the difference between weather and climate? So people, again, everyday speech sometimes interchange these two, weather and climate, but in science, they mean something very different. So you may have watched the weather on television, but you may not have quite as much experience of climate. Okay, so it's important to look at these two different things. So weather is what's happening in the atmosphere on a short-term daily basis. So if you've watched my other videos, I talked about the atmosphere quite a lot. So the atmosphere is a layer of gas that surrounds the Earth. Okay, so the weather is what's happening on a short-term basis. So you could say something like, today is windy, or today is looking outside now, it's cloudy where I am. Say it's cloudy. Or yesterday it was sunny, which it was actually here. Yesterday it was sunny. So it's very short term, or we think you say this evening it will rain. Okay, so it's what's going on very short term, so now, okay? And climate is a long-term average of temperature, rainfall, or other conditions. So for example, so it's often like data, okay? So it's the average temperature in February is 7 degrees, okay? So that'd be the average temperature in, so, or you could have a place. So it's just where I currently am. The average annual rainfall for Peterborough is 679 millimeters. So you can look up where you live and look at your average rainfall, okay, all over the world. There'll be somewhere that records it. Yes, that's my nearest big city. But so you have maps like this. I'm just showing you about averages. So climate is a long-term average. So it's over a year, several years. Okay, so the climate. So yeah, it's generally a bit more scientific the way you speak about it. So it's showing here average rainfall amounts. So there's certain areas of the country which get more rainfall than others. So this is to do with climate. Whereas weather is very short term. It's you could say something like there was a thunderstorm last night. That will be the weather, okay? But it's not a thunderstorm every day. Or you could say something like a general term. You say that the Sahara Desert has a very hot climate. Okay, so yeah, because it does. It's most of the time it's very hot. I mean, it could be colder sometimes, but its climate is generally on average hot. Okay, or the Antarctic is very cold. So just a bit of a recap, okay, about how Earth's atmosphere came to be the way it was in the first place. So how have we got to this point? So yeah, when the Earth, it's a bit of a brief one because it was covered in other videos, but yeah, a bit of a recap. So when the Earth was first formed, it was molten. So it's like a big ball of magma, sort of lava. So there was no atmosphere when the Earth first formed. It didn't start with one, okay? So as the Earth cooled down, the volcanoes erupted. They erupted water vapor, carbon dioxide, other gases, nitrogen, hydrogen, helium. When it first started, there was little to no oxygen on Earth, so we didn't start with oxygen. So the atmosphere of the early Earth was similar to that of Mars today. So at the time of recording, there's this, in the last few days, there's been a Mars rover sent to Mars. People are interested in Mars because, yeah, it could be like the early Earth. Okay, so it could be like Earth a long time ago. And also looking at whether life could be on it now or in the future or in the past. Okay, so once the Earth cooled down, the water from the volcanoes, remember, condensed because volcanoes actually got quite a lot of water vapor, actually, more than you think, because lava's got a lot of water in it. So the atmosphere cooled down over time and condensed to form the oceans. Comets, so you got a nice bit. I found this photo, little comet there. Sorry, drawing, drawing of a little comet arriving, because comets are mainly made of ice and rock, and they could have brought a lot of water to the Earth. So that's one of the theories there. Okay, and where did we get our oxygen from? So algae, like you find on ponds today. So they were around and were one of the first organisms to develop on Earth. Okay, they're quite simple, but they took they're very important though. They took the carbon dioxide out of the atmosphere and they gave out oxygen. So think them, they're still doing it today. They're still doing their job today. Okay, that's where oxygen came from. That's how we get our atmosphere today. So this is a good graph. I use this quite a lot. Okay, this is the it looks like there's a lot going on, but you can sort of have a general idea. Okay, so here's now. So this is millions of years before present. This is going back pretty much as far as we can to near the beginning of the Earth. Okay, I'm going to go out so far, can't we? This is now. This is millions of years before present, so it's going back. Okay, so this is the purple line is purple line is carbon dioxide. So it does change throughout time. So yeah, we start with lots of carbon dioxide. We've been decreasing on average ever since. Yeah, it went up and down a little bit, probably due to volcanic activity. We'll talk about a bit more later, but it kind of goes up and down. But as you can see here, there's no uptick. So we think this is probably most likely humans, because it's not been increasing volcanic activity. This is the temperature in sort of like a teal color, nice bluey teal color, and it's gone up and down throughout history. But it's mainly been lower for a long time, and again, humans are increasing that. Okay, so in the last about 2 million years, it's been lower due to the ice ages, but humans are upticking it. But this is, yeah, that when people say, well, yeah, climate has changed throughout history, geological history. Yes, it has. Yeah, but long-term averages is it going down? And we're sort of putting it up. So yeah, some people will talk about, well, there is natural causes. So we'll talk about that. Okay. So the first one, climatic change. When I say this, I mean like on a general scale, is that natural things can cause the climate to change. Yeah, as we saw in history. So orbital changes are one of the things. So the Earth's orbit and its tilt changes slightly over thousands to millions of years. So the Earth's orbit can change from sort of an oval shape to a circular shape and back. It's a cycle, so it goes circle to oval. It's millions of years. Like we human lifetime wouldn't notice it. Okay, but it does change over millions of years or thousands of years. Some things are shorter term. The tilt changes of the Earth. So at the moment, yeah, so we're at 23 degrees, but and that's what's called the seasons. Okay, so it changes over time, and the Earth wobbles on its axis. Okay, so these three things, just eccentricity is how circular the Earth's orbit is. The tilt, yeah, it's just called the tilt. And the precession, this is called. So it's a bit like if you spun a spinning top and it wobbles. That's actually what the Earth does over thousands, millions of years. So what this does, it affects how much certain parts of the Earth receive in energy from the sun. So you've got the sun there, like shining for a long time over there. So sometimes, obviously at certain tilts, the northern hemisphere will receive a lot more in the summer, and other times it will receive a lot more in the winter, and that can lead to ice ages. So example, if it's tilted away the northern hemisphere more of the time, that the ice doesn't melt and it builds up. Okay, but yeah, that's cool. They're called Milankovitch cycles after the scientists who explained them, Milankovitch, and they're very interesting. So good to do your own sort of research on that. Some of my master's degree science is to do Milankovitch cycles. It's very interesting. The whole field of science has been based on it. Okay, so what else can change? Sorry, got a bit there. So volcanic activity can actually change naturally, can change it. So this is what we thought were maybe responsible in the past for changes was other than the climate, due to the orbital changes. Okay, it also could be volcanoes. Okay, so they emit carbon dioxide, sulfur dioxide, and ash. They still do today. Okay, they're still doing it. So the ash can blot out the sun, causing the Earth to cool down. So this is what may have helped, well, may have like aided in the poor dinosaurs dying out is a lot of volcanic activity cooling the earth down, and plants couldn't grow, and so had nothing to eat. Okay, and the greenhouse gases cause the earth to warm up. Okay, so it's two effects that can happen out of volcanoes. Also, the sun. Okay, not mentioned that much, but solar output. So the sun's energy, just naturally because it's a star, it varies over time. Okay, so yeah, it goes in cycles as well. So it goes a little bit dimmer. I mean, we don't notice it with our eyes, but scientific instruments can notice it. Okay, so it varies over time. So actually, though, in the last 50 years, the sun's become slightly dimmer. Okay, just as part of its natural cycle, nothing to worry about. Okay, and temperatures actually increased on Earth. So yeah, the sun's not a big effect in this. Okay, but it could be on a question, a paper you've got about the sun. Okay, what are humans doing though to actually increase the temperature? So we've got obviously burning fossil fuels, so coal, oil, and gas release carbon dioxide into the atmosphere, which makes the greenhouse effect stronger. Okay, warming the earth. So us burning the fossil fuels, like for our cars and things, warms the earth up. Okay, agriculture. So especially cattle, they have 4 stomachs in which they digest food. Okay, so what that does actually is it breaks down plant matter, and it releases and they release methane into the environment. Okay, so by burping, actually, that's quite funny. You will remember that by burping. Also, though, rice farming, because they farm rice in flooded fields. Some of the organic matter, so some of the plant matter, sits in the water and is broken down by bacteria. Okay, and that releases methane into the atmosphere. So that's another thing. And methane is a very strong greenhouse gas. But also deforestation. So humans are cutting down big forests to make way for farmland, to farm cattle or other crops. And the problem is that forests, like the trees, obviously taking a lot of carbon dioxide from the atmosphere and they release its oxygen. If we cut that down, more carbon dioxide will stay in the atmosphere. Okay, so there are 3 main points there to remember, to note down. How will that affect the climate? Okay, so as the Earth warms, the ice at the poles and the glaciers on land, so glacier is ice on land, okay, that will melt and there will be obviously sea level rises because of all the water entering the oceans. And also the loss of habitat for animals in the polar regions. So animals that live there, like the polar bears and things like that, will lose their habitats, okay? And coastal areas, so that's near the sea, will be flooded. Okay, so it could be loss of habitat for animals there. And people will find out later on. Okay, so this is another really important one. Okay, so many animals may become extinct or endangered. So coral reefs are very sensitive to temperature. If the water warms up, a lot of these corals are animals, they will not be able to live in that water and they will die out. Okay, but many animals like the fish, they rely on the coral reefs for food, okay, and places to live. So if they die out, huge ecosystems will collapse, okay, with the coral reefs. And also on land, other life may be affected as the climate may change where they live, and the plants may not be able to handle kind of the conditions. Okay, so it could be not enough rain or too much rain, and then the animals that rely on the plants to eat, obviously for food, they'll die out as well. So there could be lots of problems caused by it. Also, warmer temperatures, so especially in the ocean, so it's the water temperature is a very important one as we go, isn't it? Will lead to more favourable conditions. So it'd be easier to form hurricanes and tropical storms because they need a certain water temperature to form. Okay, so extreme events such as hurricanes, high winds, flooding will become more common, but also other parts drought. Okay, so other parts may become more dry, so it's not more rainfall everywhere. So it's a bit unpredictable. So how will it affect people? Okay, so in some parts of the world, there may be crop failure. So it means that the crops like the wheat and the rice and oats that we depend on will not grow. So it could lead to people starving as they cannot grow enough food. Obviously, a very serious thing. Heat-related illnesses will become more common as the world warms. And also, again, like the animals, that people that live near the coast, I mean, quite a lot of people do. I live not that too far away from the coast. Okay, will lead to flooding. So people will have to obviously move away from those areas and into other places, away from the coast, which could lead to overcrowding in cities. There might not be, again, enough resources, like food and water and things like that for the people in the countries. Okay, so yeah, quite serious things, and it overlaps with geography, this one. Okay, so let's have a quick look. So a bit more evidence. So 10 hottest years on record globally. They've all been in the last 20 years. Okay, so 2019, so the year just before last. I think we're still getting the data in for 2020. So this is our latest records. Yeah, data as of that. Okay, so yeah, 2019 is one of the hottest, but they've all been fairly recently the hottest years on record. Okay, so this is a copy incomplete. This is like a sort of a stop point. Okay, so to summarize all of the work, so I like to have a go at this. So it's a summary of what we've all been talking about. So it gives me a guide on what to write. Okay, so we sort of copy, so attempt that itself, that'd be a good idea. Okay, answers. So yeah, summary of what we've been talking about then. We talked about quite a lot of things, haven't we here? So got a lot of things in one video. So weather is what happens on a short-term daily basis. If it is very cold and snowy today, that will be describing the weather. The long-term average of temperature and rainfall amounts would be climate. So for example, as I said earlier, the climate of the Sahara Desert would be hot and dry. The average climate of the Antarctic would be very cold and dry. Okay, it doesn't snow very much down there, so I added that in a little bit because actually the Antarctic is classified as a desert because the desert doesn't have to be hot. Okay, it's just about its rainfall. So the 10 hottest years on record have all been recorded in the last 20 years. The temperature of the Earth has been increasing over time. Okay, so well, after what we have been measuring. Okay, so although all of the Earth is getting warmer on average, not all places will become hotter, and that's why we put climate change. Okay, so some places may become colder or wetter or drier. This is why we call the effects of global warming climate change. Yeah, the climate change can lead to ice caps melting, animals becoming extinct, floods, and droughts. So drought is like less rainfall. Okay, so now you'd be obviously in a good place to answer this question. Okay, greenhouse gases cause global climate change. Give 2 effects of global climate change. So obviously using this video, there's lots we can write. So let's think of examples. Let's put a text box in so we can write. Okay, so obviously there's many things, just 2. Okay, but I'll give some examples. 2 effects of global, so as we've just gone, ice caps melting, that'll be 1. Okay, so you could say droughts and crop failure. Okay, there's many in this list, isn't there, obviously. Flooding of coastal areas, loss of habitat for Arctic animals. Okay, humans could become displaced. Okay, so obviously it means that they have to move. They may need to migrate, which would lead to overcrowding. Okay, and also also the weather. So pick 2 out of these things for your answer. I'm just sort of giving you more information. Also, the weather will become more extreme. For example, greater numbers of hurricanes and tropical storms. So, marine life, you've got about the coral reefs. Marine life will become endangered or extinct due to the collapse of coral reefs. So just pick 2 out of those. This is an exam question. Okay, yeah, so there's a lot of information given to you in this video. So it's a video so you can sort of stop and rewind back. But yeah, it's a sort of try to give a general summary of all the things that happen. So we need to know about natural causes of climate change, human causes of climate change, and then what will happen and what could cause the effect on humans. Okay, so thank you for listening to this video. Hope you've enjoyed it, and goodbye.